The screen is visible to you?
Yes, sir.
Okay. Now we start with the application of definite time overcurrent relay. Application of definite time overcurrent relay for the protection of distribution feeder. For the protection of distribution feeder. Now, in the last lecture, it is discussed that how this electromechanical works and basic principle of that electromechanical relay. Now, in this case, we discuss about this application of a definite time overcurrent relay for the protection of distribution feeder. Now, let us consider the three-phase feeder as shown in the figure. So, where the two line sections are there, that is AB and BC, two line sections are given, and let us assume that DTOC relays, that is A and B, these are used as the buses A and B for the protection system. Now, the protection problem can be stated as, how you can state this problem? Now, this protection problem can be stated as, given the magnitude of loads and fault currents, given the magnitude of loads and the fault currents at the buses, how to set the DTOC relays at bus A and B so that entire feeder gets overcurrent protection. Protection arranged as primary and backup protection. So it means that what is the protection problem? The protection problem is that given the magnitude of the load and fault current at the buses A and B, how to set these DTOC relays, that is RA and RB, so the entire feeder gets the overcurrent protection arranged as the primary and the backup protection. Now, how to solve this problem? To solve this problem, we have to design, the first step is that for the solution of this problem, the first step is that select the ratio of CTs. select the ratio of CTs. Now, if you take the case of the CT, in that very case, we have the primary and we have the secondary. This is the primary and this is the secondary. So let us suppose this primary current and the secondary current, which is actually going to the protective system. So the primary current is decided by the what is the this actually maximum load current to be carried out. So the primary is carried out current primary. It depends upon the maximum load current. And secondary depends upon already we have the this standards for that. So it is decided by the rating of the relay and the standard relay rating. We have 1 ampere, 5 ampere. So it is decided by that. So next, this is the select the ratio of the CTs depending upon that. Now, next step is that we have to decide the setting of the relay. We have to decide the setting of relay. Now, the setting of the relay, it consists of the two components. It consists of the two components, that is how to select the pickup value of the relay and second is how to decide the operating time of the relay. Now, as you know, the pickup value of the current is actually the current at which the relay will pick up. So it should allow how to set the pickup value of the relay. Now, the pickup value of the relay should be such that it should allow the normal current to flow through it. However, it should allow the permissible overload. That is, it means that the maximum load current, it should be greater than the maximum load current. And however, it should be sensitive enough to take care of the minimum fault current. It means that the pickup value should be sensitive enough to take the minimum fault current. So it should be greater than the maximum load current and minimum than the this less than the minimum fault current. So this is will be the range of this pickup value. So it can be explained with the help of this diagram. That is the, let us suppose that it represents the current. This is the load current up to that. And this is this after this fault current occurs. It means that we can have, it is only the current which decides that fault occurs or not. High value of the fault is actually gives us the indication that the fault has occurred. Now, let us suppose that this is the minimum fault current, this is the maximum fault current, this is actually the load current, and this is the rated load current. So some permissible 20% overload can be permissible in that. So we have the setting in between that, that is the maximum this load current with the 20% overload, and then you can say that minimum fault current. So it should lie between greater than the maximum load current and less than the minimum fault current. So we have to set the plug setting in such a way. It means that it should be, it allow the maximum load current, and it should be sensitive enough to respond to the smallest this fault current. So this is about the first point. Now, second is the operating time of the relay, how to decide the operating time of the relay. So how to decide the operating time of the relay? So how to decide the this operating time of the relay? Now, this is actually the operating time of the relay is actually decided based on the fact that it must get a chance to protect the zone under the primary protection. And if the primary protection does not clear that particular fault, then in that very case, the backup protection should initiate the tripping. As we have already discussed in the previous lectures, that if the primary protection does not operate, it is the backup protection which is coming into play, and both start operating at the same time. However, the operating time of the primary protection is less than that of the secondary protection, and you can say the primary protection is first to operate. So if you take the case of the relay operating time in both the cases, let us suppose that we have the this let us suppose, if you take the case of this diagram, this figure, since we are protecting the this BC portion, so BC acts as a this RB acts as a primary protection for BC, and this RA acts as a backup protection for BC also. So primary protection for the BC is provided by this RB, and backup protection is provided by RA. Now, so let us suppose this is the RB operating time, and this operating time of RB, let it be represented by TRB. Now, operating time is there. Now, after that, certain amount of time is required for the circuit breaker to operate. So then we will have the circuit breaker time, which is represented by R circuit breaker, and this T circuit breaker. So, and some more amount of time is required, because we can say that it is not instantaneous. That operation is not very much instantaneous. A certain amount of in milliseconds or seconds, certain amount of delay is there because of the relay mechanism, and which continues to move. So that kind of time is required for that, and this time is known as the overshoot time. That is small amount of time which is known as the overshoot time. So overshoot time of the A. So this overshoot time is actually the time is because of the movement of inertia of the moving system. So if you take the case of the time of the A, operating time of the A, that is TA, it should be, that is, this is equals to TRA. So TRA, it should be greater than TRB plus T circuit breaker B plus T overshoot A. So it should be greater than that. It means that operating time of A should be greater than the operating time of this B, plus circuit breaker time of B plus overshoot time. So since B is providing the you can say that it is providing the this primary protection to that, and A is providing the backup protection. That is B. This is providing the primary protection to section BC, and this is providing the backup protection to the section BC. So we can have TRB plus circuit breaker B plus overshoot time. So TRA should be greater than this amount of time. Now, in the light of above discussion, you can say that if you take the case of this setting of the relay, this is about that how we select the pickup value. Whether we have to select the pickup value of the relay, then how to decide the operating time of the relay. We have done we have seen that how we have to find the operating time of the relay. Now, the correct procedure. What is the procedure for the setting of the a relay. Now we start the setting of the relay. So whenever any protection is involved in that, we have to start the setting from the tail end of the relay. So which can anyone can tell me that which is the tail end of the relay of the system? Can anyone can tell me which is the tail end of the relay of the system? Which is the tail end of the relay of the system? Yes. Hemant, can you tell me that which is the tail end of the relay of the system?
Yes, sir.
हाँ कौन सी है? टेल एंड ऑफ द रिले कौन सा सिस्टम का इसमें? बिस्मा,
Yes, sir.
can you tell me that which is the tail end of the relay, this of the relay in this particular system?
No, sir. Sorry, sir. No idea.
Okay, since this is the source and this is the relay A, this is the relay B. Arun? So this is the source, this is the relay A, this is the relay B. So relay is actually the tail end. It is at the tail end of the system. You can say that this is at the tail end of the system. So because this here we have the source is connected here. This is the relay A, this is the relay B. So it is at the this relay is at the tail end of the system. So we start the setting at the tail end of the system. We start the setting of the relay at the tail end of the system. Why we start the relay at the tail end of the system? Because this relay B, it doesn't have any relay to coordinate with. So that's why we start the setting at the relay B. So this relay doesn't have the coordination with any other relay. So we start the setting at this relay B. We start the setting at this particular relay, that is B. So this relay at the end of the radial feeder, it can operate without any delay. There is no delay involved in that, and it doesn't have to coordinate with any other relay. Now let us suppose if you take the case of this time of that, let us suppose that time of this particular relay, let TR be the time of this relay is 0.1 second. Then circuit breaker, it is, let the time of this circuit breaker is 0.5 second. Then let us suppose overshoot time is 0.2 seconds. So total TRA should be, that is TRA, it should be greater than 0.8 second. So TRA should be greater than 0.8 second. So we can say the time step between the operating time of two relays, which is equal to sum of operating time of this, you can say the circuit breaker time and overshoot time of the relay A, is essential for maintaining the selectivity between the relays. Is essential for maintaining the selectivity between these relays, and the interval is referred to as, this time interval is referred to as, between A and B, it is known as the selective time interval. It is known as the selective time interval. Now let us discuss with the help of this worksheet. Now we have the primary protection is provided by the BC, and the relay in that very case is RB. Now pickup value, it should be greater than the maximum load current. Some overload is permissible, and minimum than this minimum fault current, and this time is 0.1. So backup protection by RA, and this is the pickup value of this backup protection, and then we have the time that we have discussed, that is TRA should be greater than this 0.8, then selectivity is maintained this between these two. So now one more point is that the setting process has to be started from the relay, which is the tail end of the relay. This is because of the fact that you can say that this relay is not constrained by this relay does not have to coordinate with any other relay, and it is not constrained by any selectivity issues. All the upstream relay are tied up with the downstream relays. Now, now one more point is that as we have discussed also in the previous lectures, that as we are moving towards the source, what happens? As we are moving towards the source, the fault current becomes larger, because as you know the fact that impedance is reduced, as so the fault current becomes larger in that very case. So as we are moving towards the source, the fault current becomes larger. However, as per our setting, what we have done the setting here, as per our setting, this one of relay RA, the clearing time becomes smaller. So it means that as this fault current goes on increasing, the operating time of this relay uh, RA, it also goes on increasing. So we can say that as the fault moves towards the source, the fault current becomes larger, and the source are deliberately delayed so that they are selective with the downstream relays. So you can say that the relay nearest to the source are deliberately delayed to so for the selectivity of this for the relay. So relay nearest to the source, we can say that these are the slowest. This relay near to the source, these are actually the slowest, which is not desirable because of the fact that near the source the fault current is high. However, the relay which is nearest to the source is the slowest, which is not desirable, which we have set due to the selectivity issues. To solve the selectivity issues, we have set that time, and as the fault current is increasing, this as we move towards the source, the because of the coordination issues, the operating time of the relay would be high. So this is not desirable because current is more and the operating time is low. So which is not desirable in case of the DTOC relays. So this is not desirable in case of DTOC relay. However, a significant improvement in fault clearing time is obtained significant improvement in the fault clearing time is obtained when we as we move towards the source when we are using IDMT relay. So significant improvement in the fault clearing time is obtained when we are using IDMT relay. In the next lecture, we can discuss this IDMT relay. Now, what are the questions which arises from this type of relay? Is first is what is DTOC relay? What is DTOC relay? Now, second one is that what are the steps involved in the designing of this DTOC relay? And then after that, you will have how the setting of the relay can be done. Please mute the mic. Fourth one is how to select the pickup value of the relay and operating time of relay. Select pickup value and operating time. How to select the pickup value of the relay and the operating time of the relay. And fifth is how to select the current values of CT. Then after that, we will have why the setting will be started at the tail end of the relay. And then after that, we will have what are the problems associated with the DTOC relay. So first one is that what is DTOC relay? Steps involved in the designing this DTOC relay, how the setting of the relay can be done, then how we select the pickup value and operating time of the relay. Then after that, how to select the current values of CT, why setting is started at the tail end of the relay, and the problems associated with the DTOC.